Hello, you welcome back. All right, so here we have a question that we are gonna do justice to. Okay, still on electromagnetic induction. So let me put that very well. Here we go. So now we are gonna be dealing with problems. We deal with problems, and of course their solutions. So these are typical examination problems. Okay, so now the very first question here. It goes this way: a coil of 500 tons. So I have to write the parameters. The number of tons of the coil is 500. The area of the coil is 10 centimeters square. Each place uh, with each plane perpendicular to a magnetic field of uh, course of field density. Okay, that's B, symbol B, field density 2 times 10 raised to the power of minus 3 Tesla. If the field be uniformly reduced to zero, okay, so this was the initial value of the flux density of the field, okay, then the final value was actually zero. It was reduced to zero. B2 was reduced to zero. And that happens within the interval of time of 10 raised to the power of minus 2 seconds. So the question is, what will be the EMF induced in the coil? So simple. EMF induced in coil, you know that, okay, that's going to be change in flux, which you've already evaluated to be equal to BA, please pardon me, NA, then B2 minus B1, then divided by the change in the time. Okay, so the total number of turns is 500. And here the area is 10 centimeter square. You need to convert the cm square. Okay, since we have to the voltage, the EMF that I want to evaluate is still gonna be the I'm gonna use the SI unit of the voltage, so I have to convert the centimeter to the SI unit. So converting centimeter square to meter square. Okay, of course, first you have to convert cm to meter. If you convert cm to meter, 10 cm to meter will give me 0.1. And of course, you have to square it, all right, to make it meter square. 0.1 then squared. Okay. Then now the final B2 is 0. Okay. B2 is 0. Then minus. Don't forget that there was minus. Okay. I made a mistake. From Lenz's law, I have to put minus. Okay, so 0 then minus that's B2 minus B1, which of course is going to be equal to 2 times 10 raised to the power of minus 3. Okay, so let's actually evaluate that. So here I'm having 0 minus 2 times 10 raised to the power. Of course, that will give me, this is going to be still minus 2 times 10 raised to the power minus 3. Okay, then minus times minus, of course, you know that's going to be plus. Okay, so the minus times minus actually cancel out to give me plus. So I'm left with 500 multiplied by 0.1 square. So I'm going to get a calculator. Here we go. Okay, so 0.1 square, you know very well that that should be 0.01. Okay, then multiply by 500. Multiply that by 500. That should give me 5. Then multiply that by 2. That gives me 10. So I'm having 10 times 10 raised to the power of minus 3. So if you should Do this same as 10 divided by 1000, which should give me 0.01. So the induced EMF is 0.01 volts. That is the induced EMF. Okay, so I hope that is well understood. As simple as that, I'll pick another question. Okay? I have another question here that I want to do justice to. Okay, here we go. I clean up. Okay, so here I bring it to the screen. Please pardon me. Okay, let's work. So this question goes this way. Find the magnitude of the induced EMF. So let me use E this time around. Induced EMF, question mark. Okay, in a 200 turns, the number of turns is 200, comma, with cross-sectional area of 0.0.16 meters square. If the magnetic field through the core changes from, okay, B1 being equal to 0.10 Tesla, then B2 equal to 0.50 Tesla. Okay, at a uniform rate over a period of 0.02. The time is 0.02. All right, so the same formula A is going to be equal to minus NA bracket open B2 minus B1, then divided by the change, okay, the change in the time T. So here we're going to have minus 200 multiplied by 0.16 meter, then I have going to be B2, which of course is 0.50 minus B1, which is 0.10, divided by the time for that change. That change occurred within 0.02 seconds. Okay, so here we go. So let's flow 0.0 to, oh, please pardon me. I'm having 200 times 0.16, then times 0.4 times 0.4, then divided by 0.02. So that's gonna give me minus 640 volts. So minus 640 volts is the induced EMF. I hope that is well understood. Okay, I we solve more question, okay? But let's actually conclude. There are other subtopics we need to work on, all right? So after that subtopics under electromagnetic induction, then we'll work on more questions. All right. See you in the next video. Thank you very much.